Okay, let's get started here. I posted few items today on the coursework, and you would see that these technical rules seem to have wider application in foreign exchange market. So lots of papers written on this. So I want you to look at the paper that I posted, and lots of references in the paper will lead you to other applications. You may want to take a look at it. Okay. For whatever reason, I think the applications in foreign exchange market seems to be published quite heavily. Okay. So if you look at the technical rules that we have gone through, you will see that they are all based on the same data, that is the price data, and but they all have different seems to extract different kinds of information. If you look at the filter rule, it looks like the instantaneous change, and based on the instantaneous change you make a decision. If you look at the moving average rule, it's supposed to look at some sort of trend over time, and if the current observation is in line with the trend, you make a decision, otherwise you don't do anything about it. Okay. And if you look at Bollinger Band, it looks at, in addition to the average, it also looks at the variation in the data. And then if you look at RSI index, it sort of looks at positive change versus negative change. Okay. So they all seem to extract different kinds of things. So one of the things I want to discuss here is that, can you combine these different technical rules and come up with one overall decision that you want to make? Okay. So that's the idea behind stacked indicator approach here, and I think towards the end after this I would also mention what we call the boosting method, which is very popular in data mining. So the idea behind boosting is that you have various signals that come, and you want to pool the signals in optimal fashion so that the final decision you make seems to be overall optimal. Okay, that's the idea. Okay, it's quite heavily used in classification setting. In classification setting, you have either it's true or false kind of setting, right? Here I think same idea you can go through too. You can say that how close the prediction comes to the actual values. Based on that, you can classify each rule in terms of how good they are, and then you can try to combine them in some fashion. Okay. So here you would see that this is a simple application we looked at. I think we mentioned the study type is the mean reversion, and it's a bi-directional long or short, and we focus mostly on the futures market. So here the trade execution is between 7:30 to 15, because most of this is traded in Chicago Board of Trade. So I think so we restricted to 7:30 to 3. So we looked at three indices here. One is the relative strength index, and Bollinger Band, and simple moving average. And the system we are building is something similar to this. Essentially what you see is the green and red bars that you see, they are supposed to be the price bars. Price bars means that, remember those four numbers I talked about: open, close, high and low. So those are the bars that you see, and there is a line that goes through in between that is supposed to be some sort of average price line, and then you have the two bars that is red and green, the green color bars on the top. Those are supposed to be the Bollinger Band. And at the bottom we also have volume, we also have some sort of volatility index. Okay, and most of the trading platform that you see are going to be somewhat similar structure, but they would also add additional information on the side. They would put, is there any announcements concerning this particular stock is coming up, all the other things are given. Okay. So essentially you can see that in some cases price bars either exceed the upper line or go down the lower line. Okay. So whenever that happens, that means that you can make a trade. So there are instances where you will see it comes down below the red line. There are instances where you will see it goes above the green line. Okay. So the idea behind this is that you look at this data in a moving average fashion, right? I think we looked at 60 days or something like that to see how these things can be used. Okay. Again, I want to mention that all the rules that we develop here is going to be ex ante. That is, you look at the past data, predict what is going to happen into the future, and see whether current data that you get is in line with the predicted values. Okay. So that is the approach we are going to take, and we came up with some trading logic here. There is no reason why we should follow this. This is just a test. So we said long entry and short entry, and long entry is that you can see if RSI is less than RSI lower limit, and which means that it is oversold. And then if you look at the next one, closing price is less than Bollinger Band lower limit, and then if the short term moving average minus long term moving average, then greater than 1 tick size. And we also put some simple constraints like the time of trading has to be between 7:30 and 2:30, and then we place the buying order. Okay. The reason why we limit to 2:30 is that there is no point in pushing this close to the market closing at 3 o'clock, so we just put it as 2:30. Okay. And similarly we have short entry and then long exit and so on. So you can see that roughly long entry essentially takes into account all the rules should be met, right? Doesn't have to be that way. You can relax them and test out which ones are working out better. Okay. So similarly you can see the long exit is that if any one of these two quantities are reaching the upper limit, then we are going to sell the order and then next bar and close. Okay. So this is the technique that we wanted to see how good it is. Okay. And trading logic is that if the position is held for n price bars, liquidate at next bar. N bars means that this is sort of getting out of the exit strategies that we have used. So if it has stayed on for quite some time, possibly we made enough money so we can get out of this. Okay. Trailing stop, exit, place a trailing stop on all position. Trailing stop means that if there is a huge loss, suddenly you see you want to come out of it. Okay. And then end of day exit, I think most of the trading we have is that we start in the morning and close it at the end of the day. So that's how we work out. Okay. So if you look at this, these are the ratios we have used, and you have seen, I've defined them before, and this is the these are the actual values that you get. You can see Sharpe ratio is 0.16, Sortino is 0.24, Colmar is 0.02, and so on. I think these are all by themselves are not that meaningful, but when you compare them over different trading strategies, you can say which one is better. Okay. But the most important thing is to look at this overall equity graph. Okay. So essentially what we are saying is that if we place, I think we started with $1,000 or something like that, and then you can see that initially there is a loss here. Can you see that? This is the drawdown that you see, and then generally I think overall equity curve goes up. Can you see that? Okay. Similarly you can see that there is a drop here, that's a drawdown that you see. So you need to put some stops for these drawdowns. So if it exceeds certain amount, you want to get out of the market. Okay. So this is overall equity curve. So this is one of the graph that one wants to look at. Okay. How do you know that overall it does well? I think if you look at this Sharpe ratios and so on, they seem to be on the positive side, so it should be okay. But one other graph that I would like you to think about is that if you invested this $1,000 in the beginning, at the end of whatever period you are looking at, buy and hold, how much money you would have made. Okay. So, that would be another graph that you can overlay on this, see how good this strategy works. Okay. So, that keep in mind that overall equity curve is probably the most useful graph that I would like you to create. It's same as that P&L graph that I mentioned in the class. Okay. So, one thing that we wanted to consider here is the method of boosting. So, if you are interested, you should read up on that, and the people who develop boosting, one of them Freund and Schapper are the two people. Freund has some work done in the application in application in stock market prediction. So, you may want to take a look at that, and if you don't have access to it, I will try to post that article for you, so you can read through that article too. So, boosting is one area. I think there is a lot of research needs to be done, and there is also, we also tried some sort of neural networks. Neural networks are nothing but you have these various signals coming into place, you want to combine them in some optimal fashion, and it goes for nonlinear combination, doesn't have to be linear combination. The main problem with neural networks is that some sort of black box approach, we don't know how certain things are combined. Okay. But generally, what is the idea behind combination of different forecasts? How do you combine different forecasts? Anyone? Suppose you have two forecasts, what is the optimal way to combine?
Boosting random forest.
What's it?
Boosting random forest.
I can't. How do you combine them?
Through boosting and or random
Yeah, boosting
forest.
is one way to combine. But simple idea is that if you have two estimates, how do you combine, how do you get an overall estimate? You want to give less importance to the estimate that's highly variable, right? More importance to the estimate that is less variable. That's roughly is the idea here. Okay. So, let me briefly talk about that. Combination of estimates, combination of forecasts is a very combining forecast. So, essentially I think if you have two forecasts, let us say P1 hat, and the variance of this forecast is given by say S1 squared, and you have the second forecast which is P2 hat, and the variance is given as S2 squared. So, it is possible that you can get these forecasts are related to each other. So, you can also get the covariance S1 2, right. So, there are various methods people have talked about. The first method is that you can look at the one with higher variance should get less importance. So, you can say that 1 over S1 squared P hat 1 plus 1 over S2 squared times P hat 2, this divided by 1 over S1 squared or 1 over S2 squared. This is one approach that you can take. And the second one is that, second approach is that you may want to take into account the variance, covariance information. So, the way they do it is that they look at P hat is equal to some sort of inverse matrix. So, you want to get covariance matrix of this quantity here, which is given as S1 squared and S2 squared, sorry S1 2 and S1 2 here S2 squared inverse times P hat 1, P hat 2, and then you can combine them in some fashion here. Usually you can take it as some 1 prime this quantity here. Okay. But in practice I have noticed that even if you don't worry about the variances, taking simple average works better than using any of them over time. Okay. So, usually I don't even worry about the variances, I just take the average of these quantities here and see. Generally this tends to work out very well overall in time. Okay. So, keep in mind that this is the idea of using stacked indicators is to see how we can combine different forecasts. Is it in line with what you are saying? Okay. Yeah. Good. Okay. The next topic that I want to mention is the pairs trading. Okay. So, this is an area where I have done some work and also some thinking. So, I am also going to introduce the co-integration method to do this. Okay. So, what exactly the idea behind pairs trading? I think the company that exploited this idea is the long-term capital management, and and the idea is that you want to identify two stocks with historical prices moving together. So, when the spread widens, you want to short the winner and buy the loser, mainly because you will see that when you short the winner, buy the loser, these two are supposed to catch up with each other. In the end, loser will catch up with the winner. That's the idea. Okay. So, you are going to buy it cheap, and when the prices converge, you are going to sell it high. Okay. So, if the history repeats itself, price will converge and arbitrager will profit. And if you want to read two papers in this area, I would suggest that this is one paper you should definitely read. It sort of, lays out the ideas behind pairs trading. The second paper is by John Scruggs. I think he took a very concrete example and showed how it is done. It came in Journal of Financial Markets. I think both papers have posted on the coursework. You should be able to check it out. Okay. So here we are going to look at this data here, Royal Dutch Petroleum and Shell Transport, and the twin charts implies that this should move together at a ratio proportional to division of the cash flows, but you will see that surprisingly the prices of twins do not behave in this manner. Okay. So, this is sometimes known as Siamese twins. Okay. In genetics, I think that twins are fairly common, right? They are supposed to have identical gene makeup, whereas when it comes to financial companies, how do you decide they have the same genes? Okay, the idea here is that both have come from the same parent company, so you should expect them to be same. Okay, so this is the setup that we have. So Royal and Shell are independently incorporated in two different countries. And then I think there was a alliance, 1907 alliance, where they are supposed to merge their interest with 60 to 40% basis, and all cash flows adjusting for corporate tax considerations are supposed to be split in the proportion to 60 to 40, and there is considerable public information about the relative pricing. So that's how you do that. Okay. So when it comes to pairs trading, there are 2-3 different ways people approach it. The first one that I mentioned by Gato, they look at the difference in prices and they look at the variance in the difference, and then they use, based on the differences, they pretty much use Bollinger Band idea. Okay. So you should expect the differences to be roughly the same, and when the differences exceed certain amount, that means that you want to buy the loser and sell the winner. That's the idea behind it. The second approach people have taken is this kind of approach here. They look at the ratio of the prices, and then if the ratio is supposed to be at a certain level, and if it deviates from that level, you want to make the trade. You see the difference here? Both are based on the same concept, but I think one is the distance concept. So let me write here pairs trading. Okay. So let's assume that we have two stocks with prices P1T and P2T. Okay. So, the first method is by Gatev et al. Okay. Here they look at the ratio, the difference between the two, and construct some sort of Bollinger Band on this. Let me write it as dt, then some sort of Bollinger Band on dt. Excuse me. And the second approach, I think, generally given in Scruggs' paper, is that they look at the ratio of the two, which is given as say P1T over P2T, and this ratio is supposed to be at a certain level. So, I am just going to draw this as parity level. So, once you construct this RT, essentially you can do some sort of Bollinger Band on RT. Okay. That is the second approach. Okay. And the third approach that we are going to use here is through co-integration. Okay. So, in co-integration you would see that the idea of pairs trading can be extended to any number of stocks. So, it comes very handy, whereas these two you can see, if you have 3 stocks, you have to get 2 different pairs and go through 2 different calculations, whereas co-integration sort of combines them in an optimal way. So, I think we'll spend a little bit of time on co-integration later. Okay. So, there's also an additional advantage we'll talk about here. So, when you use these two ideas here, we are going to say that you short one and long the other. Okay, that's what we are going to say. In co-integration, we can also talk about how much to short. That's a key part of this. Okay. So, before I go too far into this calculation, I want to ask you that in the trading strategies we have gone through based on technical rules, we say that either enter or exit, right? So, in some cases, I think, if you look at the contrarian strategy, your goal is to enter when the price is low and cash in when the price is high. So, when you reach a certain level, how do you know that that is the lowest that you have reached, right? So, what people do is that instead of entering at that point, they also use staggered entries. That is, you want to enter and put some money, and then you want to wait for the next observation. If it's lower than that, continue to put more money, right? So, you have to decide, instead of putting all the money at one point in time, you want to do it in a staggered fashion. Okay. There is some work being done in that area, but it's still not clear because it all depends upon the trend in the data, to decide how much you want to put in. Okay. So, let me briefly go through this. Okay. Before I do that, I want to show you the actual data that I have posted. Okay. I think this is the one. So, you can see that I posted this data on Blackboard, say on coursework, you should be able to see. So, this is the Royal Dutch. That is a Royal Dutch data. You can see from 1989 onwards, and that is the price, that's the adjusted price, and this is the shell transport data. And I think when I talk about theoretical parity, so that is the parity that is given here. You can see that 1.18 and so on. So that is the observed parity, and it's supposed to be, theoretical parity is supposed to be 1.1667. Okay, so that is the parity that I am talking about, 1.167. P1T over P2T is the observed parity that I see. Whenever the difference between the two exceeds some limit, that means that you can swap one for the other. Okay, so the graph that is given here is supposed to be the deviation from the parity graph. You can see that that's a deviation from the parity graph. Okay, so the key here is that somehow you need to decide what should be the limit you want to set on this, so that whenever it exceeds those limits, you want to make the trade. That's the idea. Okay, so you can use this information to set the. Here, what I did was to just use some sort of 2 standard deviation limits for this parity difference that I have. Okay, I compute this R of t, which is nothing but observed parity minus expected parity, and then look at the standard deviation of that, construct 2 standard deviation limits, and that is what is given in the graph that I posted on the graph here. That is the graph that you see. Okay, so these are 2 standard deviation limits. I've been too strict about it. It doesn't have to be 2 standard deviation. It could be 1 standard deviation if you want to get more trades. So can you see that there are opportunities for trading here? Okay, similarly there are opportunities for trading there. Okay, so in both cases you can trade. Okay, so in pairs trading, that's one of the advantages, that the downsides are, number of downsides are pretty small, but upsides are pretty good. So that's one of the reasons why people use it in practice. The main problem with pairs trading is that how do you find pairs? That's the key. Okay, there is not easy way to find pairs. Okay, so all of you with me on this? This is actually, if you look at Scruggs paper, this is all given there. You should be able to check this out. Okay, so in the same data set, if you have anyone is interested, you also have the data for Unilever PLC and Unilever NV, and this is the, so there is some parity deviations are given, and that is the graph that you see. Again, you can take this last column which gives you the parity deviations, and you can construct Bollinger Band based on that, and you can decide how it has to, when you want to swap one for the other. Okay, so in fact I think this probably will have more opportunities than the other one, because this has lots of variation in the data. Okay, okay, that's one part of it. And so what is the exact algorithm by Gato? Okay, the exact algorithm here, I just wrote it as P1T minus P2T, since these stocks are traded in different currencies. You also have to adjust for the exchange rates, right? You also have to make sure that the unit is comparable. So normalize stock prices over 1 year horizon. Normalize means that you want to make sure that they are in comparable unit, and then select pairs with smallest normalized price difference. They essentially use the simple Euclidean distance. Okay, so when you have 2 series, you can simply use the difference between the 2 series if they are comparable units. Okay, and you can also compute what we call as the Mahalanobis distance. Let me briefly give you that. So generally, I think you will see that if you have two observations. Let me write here x1 and x2. So let's assume that both are of dimension say m by 1. So simply Euclidean distance is going to be x1 minus x2 prime, x1 minus x2, right? That's a simple Euclidean distance. There is also, I think, a weighted distance like something called Mahalanobis distance that's used in practice. This is given as sigma inverse times x1 minus x2. Okay. So this sigma is supposed to be the covariance matrix of X. Covariance matrix of X. Okay. Assuming that this x1 and x2 come from the same distribution. Okay. But I think for most practical cases, we are going to assume that not the variance is the same, so we can simply use the Euclidean distance for the calculations. Okay. So the idea, I think, is that if the normalized prices moved beyond 2 standard deviation of historical difference, buy the cheap stock and sell the expensive one, and close out if the normalized prices cross. If the convergence does not happen within a specified period, liquidate that position. So that is the algorithm that we have. So here is the more detailed explanation of this. So here you would see that there is a slight difference between what I mentioned, what is given here. We are looking at not just the price difference, but the price difference square, mainly because price difference could be positive or negative. It gets a little bit tedious to do the calculation. So if they look at the square difference and then you look at the variance of the square difference, okay, both should give you roughly the same conclusion. Okay. So this is the 2006 algorithm. So you look at the price difference square. I think the key here is this first step, normalizing the price difference. So essentially what it means is that if you have two stocks and the prices are different, so you make the first number to be 1 so that you can normalize all the other values. The idea being that if you make the first number as 1 and scale it up, the graph is supposed to give you roughly the cumulative return over time. Okay, so that's the idea behind this. Again, they will say that if the pairs diverge but does not converge in 6 months, close the position. So that's the approach they have taken. Okay, what are the ideas here? Pairs trading strategy, you need to select them from same industry, and they have to be mature companies. They need to have long trading histories, similar exposure to macro factors. Okay, and look for divergence of correlation between pairs. And I think the main point of this is that the opportunities tend to be fairly rare, but not too much downside risk. But opportunities are, as I mentioned here, are scarce. Not too many opportunities you will get. Okay. Okay. I think one of the things that I want to mention here is that finding pairs. So there are a couple of ideas that you can think about. One is that using asset pricing theory to see if you can find stocks that are closer to each other. Okay. So one of the ideas that people have tried out is that you look at the asset pricing models and see how the stocks are related to the market, and then you can use that information to group the data. Say RIT minus RF, that is the excess return on the asset, and then you can alpha I, beta I prime FT, that is the market factors. If it is only CAPM, it's just going to be market factor. If it is other factors, industry factors, you can throw in anything you want here, and this is epsilon IT. Okay. So for each stock during a certain time, you can compute what this alpha I and beta I are. Okay. and you can use that information so beta I prime, so let me put it this way, beta I prime. So you can use this to estimate for each stock what this constant term and the slope terms are, and we know the distribution of these quantities here, and they're supposed to follow some normal distribution with the estimates, if you put it here, supposed to be alpha I, beta I prime, and then some sort of covariance matrix of this estimate here, sigma here. Okay. So you can form distances based on this. So if you have another stock with alpha hat j and beta hat j prime, so compute the distance between the two and select stocks that are closer to each other, and then those stocks can be used as pairs. Okay. But having said this, I think we tried out this strategy, but it doesn't seem to work too well, mainly because forecasting return is something way beyond just relating that to the market factors. There could be other factors that come into play. Okay. And also the idea behind all the algorithmic trading strategies are that you want to sort of exploit the anomalies. Okay. So this sort of doesn't capture the anomalies very well. So I would be a little bit hesitant to recommend this in practice, but I think people have tried this kind of approach too. Okay. I have actually given one assignment problem a couple of years back, and we tried to use this distance method based on this alpha and beta, but the formation was not working out well. Okay. Just to briefly. Okay. But today I think I am going to talk about co-integration method in detail. Okay. And these notes that I have given here have mainly come from Say's book. So there are a couple of pages in the book. You may want to read through that. And before I get started on this, I want to talk a little bit about the co-integration idea that we went through before. Okay. So I was going to print a set of pages, but I couldn't. Printer was not working well today, so I couldn't do that. So I'm going to go back to the notes, and I want to recall a few items here so that you can see how they are related. Okay. So this is based on the lecture that we talked about. Okay. Okay. So this is the key for calculating the co-integration idea here. So without getting too much involved here, I want to write this, whatever I have here, in terms of quantities that you are familiar with. So in the case of pairs trading, we have two stocks whose prices are supposed to be co-integrated. What exactly co-integration means? Co-integration means that the prices are supposed to be moving in the same direction. That's all. Okay. But they are also supposed to be non-stationary, which is satisfied by all the things that we have seen. Okay. So in terms of the notation here, this is going to be yt is going to be just a p1t and p2t, just a two-dimensional thing that we are looking at. Okay. And so this is supposed to be related to pi times yt minus 1 plus some epsilon. So that's a setup that we have. Okay. So in this case, this you can see this is a 2 by 2 matrix. Okay. And what does it mean to say that the process is co-integrated? Okay. So in order to do co-integration, we need to test the following. First of all, process yt should be non-stationary. Non-stationary. How do you check on the non-stationarity of this process? By checking the eigenvalues of this pi matrix. If it is close to 1, that means it is non-stationary. Okay. So, should be non-stationary. Okay, this essentially check on the eigenvalues of the pi matrix. So, you can see that pi is supposed to be a non-symmetric matrix. So, when you calculate the eigenvalues, there is no guarantee you are going to get real values. It could be complex values too, but in terms of absolute value, it should be less than 1. Okay. But now, I think the idea of co-integration comes in the following sense. So, we mentioned that you can rewrite this equation in the form of the differencing of yt and yt minus 1, which gives you pi times minus I times yt minus 1 plus epsilon t. Okay. So, if the eigenvalues of pi are going to be close to 1, then we know eigenvalues of this matrix is going to be close to 0 because pi minus I. So, this is same as writing Wt is equal to, okay, and this is, I am going to call it as pi star yt minus 1 plus epsilon t. So, if the eigenvalues are going to go to 1, we can show that rank of this matrix, rank of pi star should be less than 2. Okay. So, that's the main condition. Okay. So, usually I think, if the rank of pi is equal to 0, what does it mean? It can be the rank of pi star going to be 0 only when all the elements are 0, right? If all the elements are 0, that means that Wt, it's not co-integrated, each one has its own way of moving around, so you can't co-integrate it. So, if rank is equal to 2, obviously, it's a full rank, there is no co-integration. The only condition we need to worry about here is that rank of pi star should be equal to 1. Okay. So, if the rank of pi star is equal to 1, based on the slide that I have here, you can write this in the form of alpha and beta prime yt minus 1 plus epsilon t. So, you can see from the dimension that I have given here, alpha is supposed to be 2 by 1, beta is supposed to be 1 by 2. Okay. So, that is the result of co-integration. Okay. So, what exactly is result that we can use in the context of pairs trading? Okay. So, if you look at this, you can see alpha is like this A and beta prime is like this B hat. So, you can equate those two things and estimate, but the key quantity that goes in this calculation, you can see, is based upon the eigen roots and eigen vectors of this equation that you have here. Okay. So, without getting too much into the details here, let me briefly talk about this. So, the eigenvalues and eigenvectors correspond to that equation that is mentioned here. So, in the context of this, this is going to be sigma hat to the power minus f, and then you have pi hat minus I. So, I am going to put pi hat star. Okay. So, we are talking about this equation here, this equation. Okay. Pi hat star and then xx prime. So, in this case, this is going to be gamma 0 times pi hat star prime sigma hat of minus f. So compute the eigenvalues and eigenvectors of this, eigenvalues and eigenvectors. Okay. So if the eigenvalues and eigenvectors are given by these quantities here, lambda squared and so on, and a and b hat are given by that equation. So here we are looking at rank is equal to 1, and you can see that based on this you can say that alpha is nothing but alpha hat is going to be sigma hat to the power 1 half times b hat 1. B hat 1 is the eigenvector that goes with the first eigenvalue, and then beta hat prime or beta hat is going to be, you can see from, it's going to be v1 prime sigma hat to the power minus f, v1 prime sigma hat to the power minus f times C hat matrix, which is nothing but pi hat star. So that is how you calculate this alpha hat and beta hat. They are based upon the eigenvalues and eigenvectors of this equation. Okay. So all these things are automatically done in many of the programs, so you should be able to use them very easily. So you can see that how many what should be the rank you want to consider. This based upon canonical correlations, you can go through the test. But here I think I am going to focus mostly on the applications. So let me briefly talk about this. Okay. So I want to show you the data that I want to go through. This is exactly the example given in Say's book. You may want to check it out, but I am doing the calculation slightly differently, mainly to show you how alternatively you can do the calculations. So let me read the data that I have. This is based on 2 stocks, and I have posted the data set on the Blackboard, so you should be able to, on the coursework, you should be able to check this out. So that is the data. I have done some of the calculations. Okay. So it gives you data from 2002, July 1st onwards, it gives you the information. So there is also the 2 stocks that considered are BHP and Whale, and this is the adjusted closing price for one, adjusted closing price for Whale. Okay. So let me show you this. So I'm going to do the plot of the data. So I think I have already done it. Let me not do this again. Let me show you the graphs here. I think I posted this also on the coursework. You should be able to check this out. So let me do the following. So when I plotted the data, that is the plot that you see. Okay. I think it's are the 2 series stationary? These are the 2 series. You can see both series are non-stationary. So that sort of goes through the idea that is mentioned here, and we can check what should be the order of this series. So I want to do some R calculation just to show you how this works. I think the time series package I am using here is MTS package, which is developed by Ray's book, so you may want to check that out. So let me show you what I have here. Okay. So there is a program that I posted already, or demo for co-integration. So you need to install this MTS and unit roots, because co-integration assumes that you have unit roots. So you need to look at that. So I'm going to copy and paste it here. Okay. And let me read this data into R so that the calculations become easy. Okay. So I'm going to read this data here. So I'm going to read only a couple of files from here. Sorry, I'm going to read only the 3 items here. One is this P1T. P1T is nothing but log of this adjusted close BHP. P2T is nothing but log of adjusted closing price of the whale. I'm also going to read this residual 1 mainly because it is nothing but resulting from regression of P1T on P2T. One could show that if you have only 2 variables, there is a close connection between running the regression and checking out if the residuals are autocorrelated or not. Those are equal and going through the same calculations. So for that reason, I am going to save that. So you can see that that's reading column 8, 9 and 10. So let me, since already read, I'm just going to extract column 8, 9 and 10 so that I can use it. Copy. So let me extract this column 8 is to 10. Okay, that's data 1. So in order to check some of these things, you need to look at what is the order of this process. Okay, so in order to do that, I don't need the residual column, I just need only the first P1T and P2T. So I just want to go through one more extraction here. I'm going to call it as data 2, just to make sure that I don't confuse with the other one. So I'm going to call this as data 1. Comma 1 and 2. Data 2. So I'm going to calculate the order of this process here, and you can see what is the order that you should get. Copy. So essentially I'm taking the data that I have P1T and P2T. I want to see how much vector autoregressive lag I need to put it here. What happened here? Sorry, it should be data 2. So that's what you see. Okay. So when you run this vector autoregressive model, you can see that there are AIC says that you need to have lag 2, BIC says lag 1, and Hannon and Quinn says lag 2. I generally tend to use BIC because they tend to give you more parsimonious model. Okay. So you can use AR2 model too. Okay. Which if you use AR2 model, the calculations get a little bit harder. In fact, if you look at Say's book, he uses AR2 model, I tend to use BIC more than AIC because it's fairly easy to use, and most of the time I found the models you get out of BIC are more parsimonious models. Okay. So essentially what we are saying here is that this model that we started with seems to be okay to start with, pi of yt minus 1. Okay. Now you want to check, the co-integrating relationship here. How do you check the co-integrating relationship? Let me show you that. Okay. So in order to check the co-integrating relationship, I am going to use this data here. I have it here. I'm going to use this M2, which gives me the co-integrating relationship. I posted here, so you should be able to know. I know what I did. Copy and paste it here. So we want to look at this co-integrating relationship based on data 2. Sorry. To make it change to data 2. I think use the summary of M2. So that's what you get here. Okay. And the key part of it I want to keep in mind is that you can see R is 0 is rejected, right? Can you see that 39.03? Can you all of you see that? Okay. It is rejected, whereas the R is less than or equal to 1 is accepted. Okay. So the co-integrating relationship is there is one linear combination that you can look at. Okay. What is that linear combination? You can see the first linear combination sort of goes with that. You can see it says that P1t is 1 and P2t is minus 0.7177. So that is the co-integrating relationship that you get. Okay. So essentially this beta prime that we are talking about here is given as beta prime yt minus 1 is essentially says that this is supposed to be P1t minus 0.7177 or 78 P2t. So that is the combination they say that should be used. Okay. So what is the idea behind that combination? This combination is going to be a stationary combination. That's the main idea. Okay. So this is supposed to be stationary. Okay. So essentially what we are saying based on this is that beta prime doesn't matter yt minus 1 or yt, this is supposed to be stationary. How do you use the stationary idea? Stationary is that whenever it deviates from its mean, we are going to be able to exploit that information. So that's the idea behind it. So what I did was to show you that combination in analysis here. So when I go through these calculations, you will see in the last picture here, so that is the combination that we are talking about. Okay. So this is the P1t, P2t, both are non-stationary. When I take the differencing, some sort of differencing here, right, with a given weight seem to be 0.7178, and you can see that that is the combination that you get here. Okay. That's a stationary. Once you make it stationary, you can exploit this information to trade. Essentially what it says is that you can go long on 1, how much you want to short here, roughly 0.7 unit of P2. Okay. So, this sort of additional information was not available when you use the simple pairs trading strategy. It says long and short. This one gives you how much you want to short. That's the main idea behind it. Okay. So, I want to briefly comment on one other approach that is very popular, and this is by Engel and Granger. It's a very intuitive approach. So, let me before I get going here, so let me write here. The left hand side is supposed to be the differencing, as I mentioned, Wt is P1t minus P1t minus 1 and so on. So, essentially when you take the difference between the log, you are looking at the return series, and this is the combination that I talked about. In this case, gamma is supposed to be 0.7178. So, that is the combination that we have. So this here Wt is sometimes known as the spread, and let us assume that the mean of this is a deviation from the long run equilibrium, and essentially going through the calculation, you can see the main thing that I want you to keep in mind here is this: alpha 1 and alpha 2 should have opposite signs. Why it should have opposite signs? If they both have negative signs, that means that the series are co-integrated, but they are going almost in the same direction. It doesn't really help you to make money. Okay, it has to have opposite signs. Okay, so you can show that by going through simple algebra that the spread does not depend on the average value of the spread. It depends mostly on the deviation. Okay, so if you put eta as the cost of trading, delta be the target deviation of Wt from mu W, which is essentially looking at some sort of Bollinger Band, and it says that by going through this, you can get the return on the portfolio is supposed to be 2 times delta minus whatever the cost is. Okay, so all these calculations are fairly easy to follow. Okay, but let me give you another approach people have taken, and this is based on Engel and Granger approach. So before I get to it, let me show you some calculations that I have done here. Okay, what exactly is Engel and Granger approach? Engel and Granger approach is that you have two series here, P1t and P2t, and essentially run the regression on P1t and P2t. So get this estimate here: P1t is equal to alpha plus beta times P2t plus epsilon t. Okay, and then test if the residuals are unit root correlated. If they are unit root correlated, then you can say that this difference between P1t and this minus beta times P2t could be taken as stationary process. Okay, so that roughly is the idea. I will derive these things next time around, but let me show you the basic analysis that we have. Okay, so when I run the regression of P1t on P2t, so this is what I get. Okay, so when I run the regression, you can see I get P1t is 1.82 plus 0.717 P2t. Okay, so what is the coefficient of P2 I get here is 0.717. It's pretty much same as the number that I wrote before. Can you see that? Okay, what was the number I wrote? I think it was 0.717, right? So when it comes in this case, it's roughly the same, but the key quantity that I want you to look at is this quantity of Durbin-Watson test statistic. Okay, what exactly we get out of Durbin-Watson? What is the idea behind Durbin-Watson test statistic? So let me write here. So Durbin-Watson test statistic is is based upon the following. You look at the residual terms, so epsilon t hat, let us say that t is equal to 2 to capital T, epsilon t hat minus epsilon t minus 1 square divided by epsilon t hat square. So, that is the test statistics that you calculate. You can show that just by expanding these terms here, you can show that this is same as writing 2 times 1 minus autocorrelation of lag 1, where this R1 is given as R1 is given as epsilon t hat epsilon t minus 1 divided by epsilon hat t minus 1 square. Or t square. Okay. So, the key idea here is that if the autocorrelation is 0, what kind of values would you get here? If the autocorrelation R1 is 0, what kind of values would you get? You get values 2, right? So, if you get numbers close to 2 somewhere here, you can say that there is no autocorrelation. Okay. If R1 is 1, autocorrelation close to 1, what kind of values you will get for Durbin-Watson? Get close to 0, right? So, this is 0 here. If the autocorrelation turns out to be -1, you will get numbers close to 4. Okay. So, if you get numbers close to 0, that generally indicates that there is autocorrelation in the data. Okay. The simple way to check. So, in this case you can see we get number Durbin-Watson is 0.18, that seems to be close to 0, right. So, there is autocorrelation in the data. Okay. So, if you go through this is a Durbin-Watson test statistic, and I looked at the residuals and I looked at the autocorrelations of the residuals. Can you see that there is high autocorrelation here? Okay. And it comes out very clearly when I use the partial autocorrelation function. So, that is the partial autocorrelation function. Okay. And that is also very close to 1. So, you can, so that sort of justified in the case of, you can see, although WT looks like that's a linear combination of the error term that I got here. So, now I want to compute these alpha values and beta values. So, one thing I done different from what is given in Ray Say's book is the following. Okay. So, I showed you that using matrix calculations how to get alpha and beta. There is a simple alternative way to get alpha 2, which is not very efficient, but I think which serves the purpose, which is nothing but you do not know what alpha is, and you have this beta hat estimate, beta hat prime yt minus 1. So, I am going to pretend that beta hat estimate that I am getting is the true beta hat. So, I am going to run the regression of regress Wt on beta hat prime yt minus 1. So, that to get alpha. Okay. So, I find that this method gives you roughly the same answer in practice. The only disadvantage is that you do not know what this standard error associated with that. It does not make too much difference. Okay. So, when I go through this, you can see the numbers I get are given here. So, that is the model that I have for P1T. Difference is given by 0.131 minus 0.7031, and then for P2T I have 0.0338 W1T and so on, and from the p-values, you can see the constant term here is significant. The p-value here shows the constant term may not be, it's also significant here. So those are the information that I would use. Okay. So essentially the model that I am fitting here is nothing but this model here. So in terms of, as you see, the Wt is supposed to be Yt and Yt minus 1, t minus 1. So in terms of our calculation, this could be taken as delta Pt, and we are fitting this alpha vector, and then we already know what beta prime is. Beta prime is 1 minus 0.717 times p of t minus 1 plus epsilon t. That is the model that we are trying to fit. Okay. But in all this calculation, the basic quantity is this quantity here. How do you get this one? How do you exploit it? That is the focus of pairs trading strategy. Okay. I still have quite a few ideas that I want to cover here in pairs trading. As soon as I finish, we will take up how do you look at triple strategies and that sort of thing. The calculations there are not that trivial. Actually, it's pretty involved calculations. Okay. I'll stop here, start on the assignment, and if there are any questions, let me know. Yeah. Thank you.